Hello everyone. So today's video is going to be quite different from what I usually post. Basically all my videos are me explaining a concept or reflecting upon a research project, right? But today's video, I want to take you guys through a journey with me, a research journey. And it's going to be basically the scientific method with us together in it, right? So I've been looking at a concept, and then right now I'm in the initial stages of research and stuff, and then and this is a video explaining that, and then when I progress I'm gonna make another video, and when I progress again, for example, let's say I'm making an experiment, I'm designing an experiment, I'll post a video on that, and then I'm doing the experiment, I'll post the video on that. So basically it's going to be us working together to discover a scientific concept. So basically this is the scientific method step by step with you. So let me explain what I'm looking at and what I want to research. So over the past few days, I've been looking at this concept of perspectives. This concept of perspectives is heavily used in visual arts, in drawings, to recreate, 3D drawings of houses, train tracks, roads. And what I found is that we can apply that into real life. And we can use that information, we can use its application to gain information on the physical world. Now, what I've been thinking is that if we can do that, if we can gain useful insights, we can, predict things, pretty cool things. I don't know what yet, but that's something we'll figure out on the way when we develop an aim and a hypothesis. But right now, it's just going to be a really rough video, explaining what I have been looking at over the past few days. So this idea of perspective, and so this project firstly is called the perspective paradox. So anyway, this idea of perspective is used in visual arts. So basically, when you're recreating a 3D object on a 2D surface, you're going to need to, reform it. You can't just squash a cube onto a 2D piece of paper and there's your 3D object. You're gonna have to mix and mash and stuff. And so usually what artists do is that they create perspective drawings. And so this includes creating an illusion of a 3D object on a 2D piece of paper. It sounds confusing, right? So let's take a closer look at this through a presentation. Okay, so here it is, the perspective paradox. So from my research, from what I've studied from right now, I've learned that there are 3 ways in which artists are able to give this illusion that something is 3-dimensional on a 2-dimensional surface. The first way is first point perspective. Now, first point perspective is a drawing method that shows how things appear to get smaller as they get further away, converging towards a single vanishing point. I think we've seen this a lot, is that if something is very close to us, it looks bigger, and then if it goes further away, it starts looking smaller. That's kind of obvious, right? And then what you do is that you incorporate that basic logic into a drawing. You show that things closer are bigger and things further away are smaller, right? Sounds simple. But then there's a kick to it. It's focusing all that smaller thing, everything gets smaller about something. It gets smaller about a vanishing point. Now that's a point where everything leads into, like, if imagine a road, an endless road, what you'll see is that the road will get narrower as you look forward, because as things are far away, they look smaller. But it will look as if eventually that road meets a point where it stops existing. It's just a dot at that point. And that's what a vanishing point is. So in this drawing of a train track, what you think is happening is that it's ending. The railroads are ending, and that's at the vanishing point, right? And so that's what single vanishing points are. And so if I was to give you a more detailed or a small insight that I had on this, is that if you imagine a 3D object, if you imagine the 3D object, right, that's going to consist of a height, a width, and a length. What you'll find in first point perspective is only one of these appears to get narrower. So in this first point perspective drawing, we can see that if we were to take this train track, what's happening is that the length of the train track is not parallel. It appears to go at a point. However, its width and its height seem to be parallel. For example, the pieces of wood that are holding the two rails together are parallel. They're not changed. And the height, so if you look at the height of the house on the left, those two lines of its height are also parallel, similar to how the two ends of the wooden block are parallel. So that's what first point perspective is. There's one vanishing point. Now in 2-point perspective, it's kind of different. This shows a 2-point perspective is similar to the first point perspective. However, in this, it shows that the object has two vanishing points. So imagine a building on the corner block. If you were to look at it, it would look as if it's at the biggest at its height, and then it appears to get smaller as shown in the image, right? And it will look as if it's ending at 2 points. Those 2 points are two vanishing points. That's why it's called second point perspective or 2-point perspective. Now, basically, this just shows an object with from the side with two vanishing points. So if we were to look at that analogy or that insight that I had before for first point perspective, is that in this, when you have a 3D object with a height, width, and a length, 2 of these appear to be shrinking, while 1 appears to be parallel with the rest of its lines. So for this instance, in this building, we can see that its width and its length appear to be shrinking into 2 vanishing points. However, its height does not. So if you look at the line that shows the height of all of the buildings, you'll find that it's parallel. They all go up. And when you look at the width or the length, they seem to be shrinking. Okay, finally, third point perspective. This is where the 3 vanishing points. I guess I'm hoping that that's quite self-explanatory from what we've learned from first point and second point. In third point, there are 3 vanishing points, creating a 3D impact on the viewer. Here, unlike this first 2, all 3, so height, width, and length, appear to be shrinking. And so let's imagine you look at the Eiffel Tower, and you're pretty small, right? You will find that it's not only shrinking from the sides, but it's also shrinking as you go to the top, right? As you look towards the top. And so those are the 3-point perspectives. Those are all of the 3 perspective points that I've researched into. Those are the only ones, because for 4-point perspective, you need a 4-dimensional object. That's what I'm assuming. Anyway, so what's my insight on all of this data? What made me think about this as a scope for research, right? So now I'll read what I wrote in my logbook. Now, from what I can gather and what I've observed about this concept, it's that it doesn't only apply to the subject of visual arts. So what I've shown can be mostly drawings, but I've learned that this doesn't only apply to visual arts, it also applies to the real world. For example, if you look at the image in the middle, that's a real world image, that's a real building, and we can see how I've explained the concept of perspective using that drawing. Now, if you take an image, right, so that's what I've done in the middle one, of an object and extend its dimensions. So, for example, let's take the second point perspective building, right? And if I was to extend its dimensions, so let's imagine the building in the middle, right? If I was to extend its dimensions, that, as you can see how it's the height, this is the height, and then it shrinks in, right? If I was to extend those shrinking in points, I'd eventually end up at a dot. And that's simple, right? That's something that we know. But what I learned from this is that with 1-point perspective, you only get 1 dot. With 2-point perspective, you get 2 dots because it's shrinking in from either side. So now you have 2 points. And with 3rd-point perspective, you get 3 dots. Now, listen to this, right? What I think we can do is that we can use, with 1 dot, we just have a dot, right? With 2 dots, we can create a line. We can connect those 2 dots and create a line. Now with 3 dots, we can connect all three of them and create a triangle. Now, what I want to know is, are these dots, if I were to connect these dots and make shapes out of them or make lines out of them, would there be anything special in that data? Would I find something, out of this world? And so this is something that's going to be my research for the next few days. Also, apart from that, although this sounds a bit confusing, I'm going to use a demonstration using a whiteboard to explain what I really mean and explain how we can get triangles from just drawings or images. So let's quickly go to the whiteboard, and that's where I'll explain what I explain in a bit more detail about what I'm actually thinking of doing. Okay, so let's look at a more detailed explanation of what I just explained. Starting with so here the three types of perspectives. We have 1 point perspective, 2 point perspective, and 3 point perspective. Now, firstly, 1 point perspective, as I said, it ends up in that it looks as if everything is going into one vanishing point. So if I was to extend the line of this road, and if I was to extend the line of this road, they would end up here at a vanishing point. Moreover, if I was to extend the line of this building, or this building, or even this building, all those lines would end up here, which is the vanishing point. If you look at all the other, so see how the width is going towards the vanishing point. That's only one of the three, right? The width is going to a vanishing point. But then if you look at the length, so if you look at this part of the road and you compare it to the end of the road, you see that these parts don't lead into a vanishing point. These are parallel. Moreover, if you look at the height of these buildings, they don't end up going to a vanishing point. They're also parallel. Okay, so that's 1 point perspective. In 2 point perspective, there are two vanishing points. So if I was to extend this building and this road, and then if I was to extend the top of this building, it would end up at a vanishing point. If I was to extend this point and this point, it will end up at a vanishing point over here, right? But if I look at the height, if I was to extend the height, they wouldn't go to a vanishing point. They would all be parallel. So that's 2 point perspective. Okay, finally 3 point. 3 point is where all three end up going to a vanishing point. So if I was to take the height of the building and extend that, they would end up somewhere here. If I was to take the width of the building, it'd end up here. And if I was to take the length of the building, it'd end up here. So there would be three vanishing points. Now, here is my insight. Here is what I've been trying to explain. So, with one vanishing point, I just have a dot. With two vanishing points, I can draw a line. And with three vanishing points, I can create a triangle. And this triangle will exist in a three-way Cartesian plane. So firstly, when I have a dot, that's one-dimensional, right? If I have a line, that dot can be over here, it doesn't matter. If it's 2 point, then I have two dots, and that means I've created a line. Now this line can be anywhere in a Cartesian plane. Let's say this is my Cartesian plane. Let's say one of the dots is over here and one of the dots is here. I can create a line. Now, when I have a 3 point, and so wait, firstly, let's go back to 1 point. I just have a line. What's that? That's my x-axis. Now I have a two-way Cartesian plane. So I have the x and y axes because now I have 2 point perspective. So x and y. And then I have 3 point perspective, which means I have three dots. And since these three dots seem to make a triangle over here, but if we were to really visualize this triangle, I think we all know that in a real image, these 2 points would be far behind this point where the height is, right? And so they wouldn't exist in a two-dimensional plane as something you see here, but rather in a three-dimensional. So it'd end up looking something like this. Now, here is my insight. With 1 point, with one dot, we can't really get any insights. Two points, we can draw lines and stuff. But 3 point, we get a triangle. And now I want to see is that, considering that these vanishing points and things are used as triangle dots, if we were to change the structures, or if we were to mess with the structures, would that impact the vanishing points, and would that impact the kind of triangle that we get? And so this is going to be, this triangle creation with 3 point perspectives is going to be my research for the next few videos. So I hope you've enjoyed this starting introduction video, and yeah, stay with me, bear with me as as we explore through this idea. Thank you. Bye bye.